let's look at two more examples of piecewise functions. I want you to understand that they are easy to do. Graph f of x equals 2x plus 3 if x is less than or equal to 1. Negative x plus 4 if x is greater than 1. Draw your coordinate axis. Make your two tables. And on these two tables, make vertical lines at your make a vertical line at your boundary. Your boundary is x equals 1. I'm getting that from right here. So on my coordinate axis, I'm making a boundary at x equals 1. I start with 1 on both tables. I look at this inequality sign and I think, okay, for table 1 I want something less than 1, which is 0. For table 2 I want something greater than 1, which is 2. When you substitute these values into this function, when you plug 1 in there, you get this ordered pair, 1, 5. When you plug 0 in there, you get 0, 3. For table 2, whenever you plug in 1, you get 1, 3, and then you get 2, 2. Graph these ordered pairs. 1, 5 over 1 and up 5. I use a solid dot. 0, 3. Go up 3. Put any kind of a dot that you want to put, because you're just using that. Draw your line through. You draw that line, make it stop at that boundary. Table 2. Go over 1 and up 3. I know I'm going to put an open circle because this inequality symbol doesn't have a bar under it. Over 2, up 2, right here. These two lines do not intersect on the boundary, and that's totally fine. They don't have to. This is the graph. You will not see this dotted line on your answer on my math lab because it's not really part of the answer. It's just, we're just drawing it on there to help us sketch the graph. Example 3. F of x is 2 plus x if x is less than negative 4. Negative x if negative 4 is less than or equal to x is less than or equal to 5. And 3x if x is greater than 5. Write your function. Make 3 tables. Draw a coordinate axis. And this time they are telling me that I have negative 4 for one boundary and 5 for another boundary. So I'm going to put those in as dotted vertical lines. And I want to know what's happening to the left. I want to know what's happening right here. I want to know what's happening right here. And I want to know what's happening right here. Plug these numbers into this in each of your tables. I know for table number 2 that I'm going to use negative 4 and 5 because I'm using both of these. Table number 1, I want something less than negative 4, so there's negative 5. Table number 3, I want something greater than 5, so I'm going to use 6. Now with those numbers, when you substitute into your expression, you will come up with these ordered pairs. Negative 4, negative 2, negative 5, negative 3, negative 4, 4, and 5, negative 5. For this last one, it's going to be 5, 15, 6, 18. I'm ready to plot some points. negative 4, negative 2, right here. I look at this, that tells me make an open circle. Negative 5, negative 3, right here. That part of that line looks like that. Plot these two. Negative 4, 4, right here, solid dot, because of that. 5, negative 5, 1, 2, 3, 4, 5, solid dot again, right here. Draw this line. We know what it looks like in the middle. And then 5, 15, somewhere way off up here, open circle. 6, 18, it's even farther up here. And I got it. That should help you understand these piecewise functions. If you have any questions, feel free to email or text.